Asian Warner 0372 transmission, a Dead Fly production, created by Brian Restrepo, Herman Angel, and Mason Ford.
This is a side view picture of our 0372 transmission. Right here you can see the bell housing, the main case, and the extension. You can see the location of the manual valve, where the tag is, and the overdrive solenoid clutch.
The AW71 transmission. This is the Toyota A40 series, Volvo BW55, AW70, 71, and 72. It is a rear-wheel drive transmission. It has been found in the Toyota, Volvo, Geo, Isuzu, Kia, Mazda, Mitsubishi, and Suzuki manufacturers. It began in the Corolla in 1973 and was used until 2005 in the Mazda Miata and the Grand Vitara XL7.
The image you see here explains what the abbreviations mean in the next cutaway image. There are three letters: C, B, and F. C stands for clutch, B stands for brake, and F stands for one-way clutch. Currently, there are three clutches. There's C0, which is the overdrive clutch, C1, which is the forward clutch, C2, which is the direct clutch, and then it goes to brakes. B0 is the overdrive brake, B1 is brake number 1, B2 is brake number 2, B3 is brake number 3, and now we have F, which is the one-way clutch. F0 is the overdrive one-way clutch, F1 is the one-way clutch number 1.
Right here we have a cutaway side image of the transmission. The first thing, starting to the left, is the overdrive clutch. The next is the overdrive one-way clutch. Next we have the overdrive brake and the overdrive planetary gear. After that, we have the forward clutch, the direct clutch, brake number 1, brake number 2, which the one-way clutch number 1 is attached to. Then we have the brake number 3, which the one-way clutch number 2 is attached to. And finally we have the front planetary gear, which is splined into the rear planetary gear.
Alright, this is our transmission completely gutted. As you see, the input shaft is right here, and this is the output shaft. Right here is the overdrive case, which holds the overdrive assembly. If you haven't noticed, this is different from other transmissions because they decided to put the overdrive assembly in the front with splined to the input shaft instead of the output shaft like in most transmissions. In the overdrive assembly, it holds the overdrive direct drum, which holds the overdrive direct clutches, and then the case holds the overdrive clutch pack itself, which is splined to the case, which is then the case is bolted to the transmission. This is one of the holding elements of the transmission. It's a multi-disc clutch pack, which are basically a clutch pack that acts like the brakes instead of bands like other transmissions. Then it goes into the forward drum, which is over here, which holds the forward clutch packs, the direct drum, which holds the direct clutch pack. This is the center support, which holds the close clutch and the intermediate clutch. These are the multi-disc clutch packs I talked about earlier, another holding element. They're also called brake 1 and brake 2 in the application charts. Next comes the lower reverse clutch pack, which is splined to the transmission's case. This is also called brake number 3. After comes a front planetary set and a rear planetary set. They're both together in the same unit, so it's called a Simpson gear set, which is made up of two planetary gear sets, which I just showed, which each consist of pinions, carrier, and sun gear. The sun gear is connected to the direct clutch pack, and the front carrier is connected to brake number 3, which is the lower reverse right here. And the rear ring gear is connected to the forward clutch pack, which is over here. And the front ring gear and the rear carrier are coupled to the output shaft. And that makes the whole system gear set.
Is the application chart for the 0372 transmission. We begin shifting into first gear by applying the overdrive clutch, forward clutch, overdrive one-way clutch, and finally the number 2 one-way clutch. First gear achieves a gear ratio of 2.825. When we shift into second gear, the overdrive and forward clutch are still applied along with the overdrive one-way clutch. The difference is that the brake number 2 is turned on along with the number 1 overrunning clutch while shutting off the number 2 one-way clutch, achieving a gear ratio of 1.493 in second gear. When shifting into third gear, the overdrive and forward clutch, along with the overdrive one-way clutch and brake number 2, are still active. The difference is that the direct clutch and overdrive brake are turned on, and the number 1 overrunning clutch is shut off. This achieves a gear ratio of 1, since everything is rotating at the same speed. When shifting to fourth gear, the forward clutch, direct clutch, and brake number 2 are still on. The difference is that the overdrive clutch and overdrive one-way clutch is shut off. The overdrive brake is turned on. This achieves a gear ratio of 0.68. When shifting into reverse, the overdrive clutch, direct clutch, brake number 3, and overdrive one-way clutch are active. This achieves a gear ratio of 2.703 in reverse.
Alright, in our transmission, when you put the shift lever in drive and you take off in first gear, what happens is the clutch in here, the overdrive clutch and a one-way clutch in here are actuated. And what it does is it locks the sun gear and the planetary carrier right here together as one piece, so that when the input shaft turns, they turn as one piece. And what that does is it sends all the turning power to the forward clutch cylinder. Now in first gear, this forward clutch, also known as C1, is also actuated. And what that does is it sends all the turning force down here to the rear planetary carrier. So that spins in the same direction as the forward clutch does. Now, the rear sun gear, because of the way it's splined in, wants to spin in the opposite direction. But a one-way clutch holding the forward planetary carrier prevents it from spinning backwards, so that you get so it only spins one way, spins with everything else, and you get a gear ratio of about 2.8 to 1. Now, if the engine tries to provide engine braking in drive first gear, what happens is that one-way clutch will actually drive itself off the axle shaft and allow the outer race to spin, so you don't get any engine braking. However, if you drop the shift lever to manual low, what happens is this right here, this is brake number 3, and that holds the forward planetary carrier completely still. It doesn't spin off, and therefore you actually do get engine braking because it doesn't spin off and spin freely. Alright, now if your shift lever is still in drive and you enter second gear, what happens is the overdrive clutch and the one-way clutch up here, they're still actuated, they're still sending the turning power to the forward clutch cylinder. The forward clutch C1 is still applied as well, which is sending the power down to the rear planetary carrier. The difference from first gear is you actually activate brake number 2, which is this clutch pack right here. And what that does, it actually holds the rear sun gear in place by activating a one-way clutch. Now what that means is, like in drive first gear, because it's a one-way clutch, if it tries to provide engine braking, it'll spin off, it'll spin freely, and it won't allow engine braking. But with this held from rotating backwards by the one-way clutch, it causes the front planetary carrier to spin in the direction with the overdrive clutch and the forward clutch. And what that does is it gives you a gear ratio of about 1.5 to 1. Now, if you enter manual second gear, what happens is you actually activate brake number 1 as well, and what that does is it actually holds the rear sun gear completely. It doesn't let it spin at all, and like manual low, you get engine braking because instead of a one-way clutch holding it, it's held solid. 1. Alright, now the shift lever is still in drive when you enter third gear. The overdrive clutch, the overdrive one-way clutch are still applied. They're still sending the turning power to the forward clutch cylinder. The forward clutch is still applied. The difference is you actually activate C2, the direct clutch. And what that does is it basically causes the entire unit to spin as one unit. Now, in a transmission, when the entire unit spins as one is when you get a gear ratio of 1 to 1, because the input shaft is spinning at the exact same speed as the output shaft. And in our transmission, that just happens to be in third gear, since typically in a 4-speed transmission, third gear would be the 1-to-1 gear. Alright, if your shift lever is in drive and your overdrive switch is on, you can enter fourth gear, which is overdrive in our particular transmission. Now, most transmissions, they overdrive the output shaft. They have the overdrive clutch on the output shaft side. What ours does is it overdrives the input shaft. So the overdrive clutch and the one-way clutch are on the input shaft. Now, they were actuated for every other gear. So to get overdrive in our transmission, you actually shut both of those off. And instead you activate the overdrive brake. Now that's splined to this housing, and what it does is it makes the ring gear in here actually transfer the turning power. It still transfers turning power to the forward clutch cylinder, and the forward clutch and the direct clutch are still applied just like in third gear. But because you shut the overdrive clutch and the one-way clutch off, what happens is you get a taller gear ratio of about 0.7 to 1. And what that does is it gives you better fuel economy and it saves you on gas. Alright, now if you put the shift lever into reverse and you actually start driving in reverse, what happens is the overdrive clutch, the overdrive one-way clutch that were applied in every gear except for overdrive, they're applied in reverse. The difference is instead of going through the forward clutch, the turning power goes through the direct clutch. And what that does is it sends power to the front planetary gear pinion via the sun gear that's in the middle of here. Now, in reverse, brake number 3 is also applied. If you remember from manual low, what brake number 3 did was it provided engine braking by holding the planetary carrier completely from moving. What it does in reverse is it still holds it, but what it does is it causes the front planetary ring gear to be allowed to spin in the opposite direction of the input shaft. Now, since the ring gear is one solid piece with the output shaft, that causes your output shaft to spin in the opposite direction of your input shaft, giving you a reverse gear, and it gives you a gear ratio of about 2.7 to 1, which is just a little taller than first gear.
Here we have the 0372 Asian Warner transmission, and we're going to go over the electrical portion of it. The 0372 Asian Warner transmission is electronically controlled in first, second, third, and driving ranges. The controls of the transmission include the TCM, which stands for the Transmission Control Module, the sensors that monitor the vehicle speed, throttle opening, shift lever position, and the brake pedal application. On this transmission right here, you'll find the park safety neutral switch right here. That will allow the vehicle to know when it is safe to start.
Right here we have the overdrive clutch solenoid, which controls the release and engagement of the overdrive.
They are spliced together right here and end up in two other connectors that connect to the rest of the harness. Other sensors that are not included right here include the throttle position sensor, also known as the TPS, and the vehicle speed sensors and the brake input. Right here you see the torque converter, which replaces the clutch in a manual transmission. It is a type of fluid coupling that can release the power flow at slow engine speeds and also multiply the engine torque during acceleration. Torque converters in newer vehicles include a friction disc that locks up to eliminate slippage at cruising speeds. The location of the torque converter is actually bolted to a thin disc, also known as a flex plate. The center of the flex plate often has a pilot identical of the nose of the converter, and the flex plate itself is bolted to the rear flange of the engine crankshaft. This has three elements. It begins with the impeller. The impeller is a driving member that rotates with the engine and is located on the transmission side of the converter. When the engine is running, the flex plate and the converter rotate with the crankshaft. The flex plate is flexible enough to allow the front of the torque converter to move forward or backward if the converter expands or contracts slightly from heat or pressure. The next piece you have is at the bottom. That is known as the turbine, and it's located on the engine side of the converter. The impeller vanes pick up the fluid in the converter housing and direct it toward the turbine. Fluid flow drives the turbine, and when the flow between the impeller and the turbine is adequate, the turbine rotates and turns the transmission input shaft. The turbine is the converter's output member. The center hub of the turbine is splined to the transmission input shaft. The turbine is positioned in the front engine end of the converter, so the turbine vanes face the impeller vanes. The last piece we have, which is actually located right in between, is known as the stator. A torque converter also contains the stator, or reactor, which is mounted on a one-way clutch. The stator is the reaction member of the torque converter. The stator assembly is about 1/2 the diameter of the impeller or turbine. The outer edge of the stator vanes forms the inner edge of the three-piece fluid guide ring that is also part of the impeller and turbine vanes. The stator is mounted on a one-way clutch that is attached to the stationary reaction shaft splines. The reaction shaft is made as part of the transmission front pump housing and is fixed and does not rotate. The one-way clutch allows the stator to rotate clockwise, but blocks counterclockwise rotation. That's it.
Our transmission likes to use a multi-disc clutch pack instead of a band. Now a band can only hold a member in place, while a multi-disc clutch pack can hold or drive any member. It's made up of steel plates and friction plates. They're always one after the other. You can never have two steel plates together or two friction plates together. That won't turn out too good. Now, they're applied using hydraulic pressure to press them together and hold the elements, and are released using either big springs or small little springs like this, which push back on the clutches and put it back into a neutral position. Alright, that's about it.
of our particular transmission, and what the valve body does is it's basically the transmission's brain. It sends fluid to where it needs to be. It'll send them through little passageways. Most of the shift valves are actually inside of the valve body. In a rear-wheel drive like this transmission, this is the middle part of the case. The valve body will be right here. This is where the transmission oil pan goes on. And on almost every rear-wheel drive transmission, that's where it will be. It will be underneath the pan. On a front-wheel drive, it could actually be in the pan area. It could be on top of the transmission, or it could be behind the torque converter. Now, some valve bodies have the TCM, the transmission control module, as a part of the valve body. Ours is a little older than that, so this would actually have a wiring harness going. It actually have a wiring harness going into the transmission control module, wherever that would be located on the specific vehicle. Now, what the valve body does is, on one side of the shift valves, it will put governor pressure, and on the other side will be throttle pressure, along with the spring of the valve itself. Alright, now with the shift valves, the throttle pressure and the spring will try to be holding it down. And when their pressure combines for more than the governor pressure trying to push it up, that's when it either stays in a lower gear or it actually downshifts if it's already in a higher gear. Now, if the governor pressure can actually push the valve up past the throttle pressure and the spring tension, then you get an upshift. And that's pretty much true on most shift valves. Now, most of the fluid that the valve body directs is actually going to go to something called the actuator. Now, what the actuator does is it's the one that actually forces bands, or in our case, clutch packs, to hold an element. It compresses them and actually causes them to hold an element. There's another thing that the valve body will send fluid to called an accumulator. And all the accumulator does is it's a piston that isn't really attached to anything, but what it does is it dampens the apply to make it a little softer and an easier shift. Now, the valve body itself will almost never go bad, because the shift valves in there are lubricated all the time. They have transmission fluid around them all the time, so they shouldn't go bad. However, dirt, overheating fluid, and plugged filters can cause it to go bad. And over time, valves can wear down. They are a moving part, and moving parts do wear. So a lot of technicians, if there are transmission problems at about 90,000 miles on the transmission, they'll just simply replace all these shift valves inside the valve body, or in today's cars they'll probably just put a new valve body in it instead of taking it apart. Alright, now this is the oil pump on our particular transmission. Where it normally is this is the bell housing, it's the front part of the case, and the oil pump will be right in here. Now, the oil pump, there are three typical types of oil pumps. There's an internal-external gear style, there's a G-rotor style, and there's a vane pump. Now, we actually have ours to where it can pull apart. You can see ours is an internal-external gear style. This would be the internal gear. That's the internal gear. This ring is the external gear, and this is called the crescent. Now, as this pump spins with the input shaft, what happens is it creates a vacuum in the areas where the teeth are not meshed, and the area where they are, it builds pressure. Now, from that pressure, it actually forces the transmission fluid out of the pump, and it puts it into the rest of the hydraulic system after it goes through a pressure control valve to keep the pressure where it should be so it doesn't build up too high. And in ours, the fluid would go from the pump into the valve body, into the shift valves, and everywhere else it needs to go.
Alright, as you see here, this is our input shaft, and this is actually one piece with the planets of the planetary carrier. As you see here, this is the sun gear. The planets are all one piece with the input shaft. And the final part of the planetary set is the ring gear. The way this works is that one element is driven, one element is held, and the last element is the output. Depending on the combination, it can create either a reduction or an overdrive. Alright, so if I just put this back together right now, this is a special ring gear right here that it has a one-way clutch where I'm able to spin it just one way and the other side is a reactionary so it doesn't spin. So now I'm going to demonstrate how the one-way clutch works. So we reattach the sun gear, which is splined to the planets. Make sure that's well in there. And lastly, we put the ring gear. The one-way clutch allows it only to spin one way. When trying to turn it to the right, there's no give at all. It's reactive. Right now, I will be speaking about the governor. The governor is a mechanical component that plays a huge role in the hydraulic controls of the transmission. The purpose of the governor is to dictate the vehicle speed to the transmission. The governor is located at the exterior base of the output shaft, as you can see. The construction of the governor consists of a spring-loaded valve that opens in proportion to the vehicle speed. The faster the output shaft spins, the faster the governor spins, as they are basically all one piece, with the bolts holding it together and clip. The centrifugal force opens the valve more, allowing more fluid to flow through it, ultimately leading to an increased governor pressure. When governor pressure exceeds throttle pressure and spring pressure, the vehicle will upshift.
Right here we have the overdrive control system circuit. As of every circuit, it begins with the battery. It goes through the main fusible link, then goes through another sub-fusible link, leading to the ignition switch. When the ignition switch is switched onto the on position, it goes through a multi-purpose fuse, which leads to the column switch and one of the wires to the combination meter. This is a zoom in of the top left portion of the overdrive control circuit. It includes the battery, fuses, and the ignition switch. This is the bottom left portion of the overdrive control circuit. At the top left, we begin with a white wire which goes to the combination meter. Spliced to that is also another white wire which goes to the alternator. Below that is a wire that is spliced from the ignition switch. That is a blue with red wire, which leads to the combination switch at the bottom, which controls overdrive off and the automatic transmission temperature, and has another wire which goes to the meter illumination light. Right here we have the top right portion of the overdrive control system circuit. We have a diode, an inhibitor switch, water temperature switch, and the overdrive off relay. The inhibitor switch is wired to the backup light and to the starter relay. The overdrive off relay is wired to the water temperature switch along